Now, we are going to take up one more problem on the elastic constants. The problem number 69. A bar of rectangular cross-section of 20 mm by 50 mm is 400 mm long and is subjected to axial tensile load of 80 kN. If the modulus of elasticity and modulus of rigidity of the material of the bar is given to be 1 into 10 to the power of 5 Newton per mm square and 0.4 into 10 to the power of 5 Newton per mm square. Determine bulk modulus, which is K, and also changes in dimensions and volume. And the length of the bar, which will be equal to 400 mm, and B, which is 20 mm, and D, which is equal to 50 mm, and P, which is 80 kilonewton, 80 into 10 to the power of 3 Newton, and Young's modulus is 1 into 10 to the power of 5 Newton per mm square, which is E, and bulk modulus, modulus of rigidity, which is G, which is equal to G or C, which is equal to 0.4 into 10 to the power of 5 Newton per mm square. So first we will going to find out what is the bulk modulus. What is E? E is equal to 9 kg by G plus 3K, which is the relationship which we have explained in our previous video. So substitute the value of E and G and to get K. So E is 1 into 10 to the power of 5 will be equal to 9 into K into G is 0.4 into 10 to the power of 5 divided by G, which is 0.4 into 10 to the power of 5 plus 3 into K. So 0.4 into 10 to the power of 5 plus 3K will be equal to 3.6K. So here on bulk modulus K will be equal to, on simplification, you will going to get it as 0.667 into 10 to the power of 5 Newton per mm square. So once you get the bulk modulus, now we need to find out what is the changes in dimensions and volumes. So what is change in length? So delta L will be equal to P into L by A into E. So what is the P? P is the applied tensile load, which is 80 into 10 to the power of 3 into length is 400 divided by area, which is 20 into 50 into 1 into 10 to the power of 5. So you're going to get it as 0.32 mm. So strain in the direction of xx, which is epsilon x, will be equal to delta L by L, which is 0.32 by 400, which will be equal to 8 into 0.8 into 10 to the power of minus 4, which is along the length is the tensile load, so it is the extension. What is the Poisson's ratio? The Poisson's ratio is given by lateral by longitudinal. So 1 by m will be equal to 3k minus 2g by 2g plus 6k. So we know that the value of 3k and you know the value of g, you substitute those two values. That will be equal to 3 into k is 0.667 into 10 to the power of 5, that we have calculated that value, minus 2 into 0.4 into 10 to the power of 5, which is given, divided by 2g, 6 into 0.667 into 10 to the power of 5 plus 2 into 0.4 into 10 to the power of 5, that is g. So on simplification, you will going to get it as 0.25. So once you get that, strain in the direction of yy, which is epsilon y, will be equal to 1 by m into epsilon x. So here, since it is the lateral dimension, it will be negative. So minus 0.25 into 8 into 10 to the power of minus 4. On simplification, you will going to get it as minus 2 into 10 to the power of minus 4. Similarly, strain in the direction of zz will be equal to epsilon z, that will be equal to minus 1 by m into epsilon x, because it is compressive strain. So similarly, so that is again minus 0.25 into 8 into 10 to the power of minus 4, which is again minus 2 into 10 to the power of minus 4. So epsilon b will be equal to delta b by b. So epsilon y we know that is minus 2 into 10 to the power of minus 4 equals delta b by 20. So therefore, change in width delta b will be equal to minus 4 into 10 to the power of minus 3, that is equal to 4 into 10 to the power of minus 3, that is 0.004 mm, which is, since it is a negative sign, so it will going to be decrease in width. So similarly, epsilon z will be equal to delta d by d. So minus 2 into 10 to the power of minus 4 equals delta d by 50. So cross multiply, delta d will be equal to minus 0.01 mm. So change in depth delta D will be equal to 0.01 mm. Since it is a negative sign, it is decrease in depth. Therefore, what is the volumetric strain? Epsilon V will be equal to epsilon x plus epsilon y plus epsilon z, which is 8 into 8 10 to the power of minus 4, which is epsilon x, minus epsilon y is minus of 2 into 10 to the power of minus 4, minus of 2 into 10 to the power of minus 4. On simplification, you will going to get it as 4 into 10 to the power of minus 4. So also we know epsilon V will be equal to delta V by V. So epsilon V is 4 into 10 to the power of minus 4, which is equal to delta V by 400 into 820 into 50. Therefore, change in volume delta V will be equal to 160 mm cube, which is finally it's a positive value. Therefore, it is increase in volume. Now we will going to take up one more problem. That is problem number 70. Calculate the modulus of rigidity and bulk modulus of a cylindrical bar of diameter 25 mm and length is 1.6 meters. If the longitudinal strain in the bar during tensile stress is 4 times the lateral strain. Also, find the change in volume when the bar is subjected to hydrostatic pressure, which is 100 Newton per mm square. Take E will be equal to 1 into 10 to the power of 5 Newton per mm square. So we know the diameter of the cylindrical bar, which is 25 mm, and the length E is 1 into 10 to the power of 5 Newton per mm square. The length is 1.6 meters, which is 1.6, that means 1600 mm, and sigma is the stress, which is 100 Newton per mm square, which is hydrostatic pressure. So what is the original volume? That is, since it is a cylindrical bar, the volume of the cylinder will be pi d square by 4 into L. So that is pi by 4 into 25 square into length is 1600. Substituting these values on simplification, you will going to get it as 785,398.16 mm cube. So what is the longitudinal strain? That is, he says that longitudinal strain in the bar during tensile stress is 4 times the lateral strain. That is 4 into lateral strain. So therefore, 1 by m will be equal to lateral strain by the longitudinal strain. That is epsilon lateral by epsilon longitudinal. So, but longitudinal is 4 times the lateral strain. So epsilon lateral divided by 4 times epsilon lateral. So that will be equal to 0.25. So therefore, 1 by m, which is the Poisson's ratio, will be equal to 0.25. Once you get this, then the modulus of rigidity is given by E is equal to 2G into 1 plus 1 by m. So you know the value of Young's modulus, you know the Poisson's ratio, then you can find out the modulus of rigidity. Substitute the values, that is 1 into 10 to the power of 5 will be equal to 2G into 1 plus 0.25. So therefore, G will be equal to, on simplification, 0.4 into 10 to the power of 5 Newton per mm square. So therefore, modulus of rigidity G will be equal to 0.4 into 10 to the power of 5 Newton per mm square. Similarly, we want to find out what is the bulk modulus. That will be equal to E is equal to 3K into 1 minus 2 by m. So again, you substitute the values of Young's modulus and Poisson's ratio. That is 1 into 10 to the power of 5, which will be equal to 3K into 1 minus 2 into 0.25. Therefore, the value of K, that is bulk modulus K, will be equal to 0.667 into 10 to the power of 5 Newton per mm square, which is on simplification. So then what is the change in volume? So bulk modulus K will be equal to direct stress by the volumetric strain epsilon V. So sigma by delta V by V. So sigma into V by delta V. So you know K is equal to, that is 0.667 into 10 to the power of 5 will be equal to sigma, you know, 100 into volume, you know, that is 785,398.16 divided by delta V. Therefore, change in volume delta V will be equal to 1178.1 mm cube. Therefore, since it is a positive value, it is increased. So next we will go to take up one more problem. So that means the problem number 71. A ball of 20 mm diameter is subjected to a pull of 50 kilonewton. The measured extension of gauge length of 250 mm is 0.12 mm and change in diameter is 0.00375 mm. Determine Young's modulus, Poisson's ratio, bulk modulus, and modulus of rigidity, which is the direct substitution problems here. P we know, which is 50 kilonewton, which is 50 into 10 to the power of 3 Newton. So length of the bar is known, which is 250, because that is the gauge length. And delta D is 20 mm, which is diameter. And delta L is given 0.12. So delta D is also given, that is 0.00375. So what is Young's modulus? Longitudinal stress sigma is given by P by A. So that is, substitute the values 50 into 10 to the power of 3 divided by pi by 4 into 20 square. So stress we got on simplification 159.155 mm square. So what is the linear strain? Linear strain is epsilon, which is equal to delta L by L, which is equal to 0.12 by 250. So that will be, on simplification, you will going to get it as 4.8 into 10 to the power of minus 4. So first we need to find out what is Young's modulus. That is, E will be equal to sigma by epsilon. So you substitute the value of sigma by epsilon, that is 151.155 divided by 4.8 into 10 to the power of minus 4. On simplification, you will going to get it as 3.316 into 10 to the power of 5 Newton per mm square. So once you get that, now we have the Poisson's ratio. The second one, that is lateral strain by the longitudinal strain, that is delta D by delta L by L. So delta D by D is 0.00375 by 20. That divided by delta L by L, which is known as the longitudinal strain, which is already calculated, which is 4.8 into 10 to the power of minus 4, which will be equal to 0.3906. So the third one is the bulk modulus, which will be K will be equal to E is 3K into 1 minus 2 by M. You know the Young's modulus, which is 3.316 into 10 to the power of 5, which is equal to 3K into 1 minus 2 into 0.3906. So on simplification, you will going to get this bulk modulus K, which is equal to 5.053 into 10 to the power of 5 Newton per mm square. Similarly, the point number 4, we need to find out what is the modulus of rigidity, which is Young's modulus, which is E is given by the relationship 2G into 1 plus 1 by M. Again, you know the Young's modulus, you substitute that 3.316 into 10 to the power of 5 will be equal to 2G into 1 plus 0.3906. So modulus of rigidity on simplification, G will be equal to 1.1992 into 10 to the power of 5 Newton per mm square. This is how we will be able to solve this problem. So if you find this video is useful, kindly subscribe to my channel. Thank you.